In this installment, what I'm going to show you is that when you combine these two, you get this. That this formula is really just these other two combined. And so it doesn't really do anything unique for us. That's really all you need to know. But in terms of understanding and knowing physics, combining these formulas and seeing how it works is an important skill to be familiar with. So looking at this formula to begin with, the first thing you might notice is the t is missing. But yet both of these have t. So that tells us that one of them we are going to solve for t and sub into the other. And if we imagine solving for t over here or over here, we could definitely see that the one on the left will be much easier. So we would begin by subtracting v0 from both sides. So v minus v0 is at. And then to solve for t, we would divide both sides by a, which gives us t equals v minus v0 over a. That's the easy part. Now comes the hard part. We're going to go stepwise here. So x equals 1/2 at squared plus v0t plus x naught. And we said that the t is v minus v0 over a. So v minus v0 over a squared. v0 times v minus v0 over a plus x0. So already we can see this is going to become kind of a mess. So the next thing we might do in this next step is to get rid of this x0 on the one side. And that gives us x minus x0 on this side. And then we have our 1/2 a, and we should deal with this squared term. So using FOIL inside there, we would, and the numerator, we would get first squared, v squared, minus 2v v0 plus v0 squared all over a squared. You could certainly pause the video and prove yourself that that's the case. Then our next term becomes v0 minus v0 squared all over a. Now, of course, we know the definition of displacement, which is x minus x0. So on the left side, we now have delta x. What I want to do with this next term is bring out the a squared on the bottom. So that's going to give us 1/2 a over a squared, which we can see will cause that a to cancel. And we're then left with v squared minus 2v v0 plus v0 squared plus v0 over a minus v0 squared over a. So since we notice that this term has an a and this term has an a, and when we multiply this through, these will all have a's. we can multiply through and either factor out the a's overall or combine like terms, something like that. But let's begin by distributing that 1/2 a. So that gives us 1/2 v squared over a minus 2v v0 over 2a plus v0 squared over 2a plus v0 over a minus v0 squared over a. Now, you might notice that there are some v0 terms and some v0 squared terms here. So changing the order that these appear might be helpful to us. Delta x is 1/2 v squared over a. These two cancel, the 2's cancel, and we're left with v0 over a plus v0 squared over, I wanted to bring them together, the like terms together, minus plus v0 over a. I just put those two next to each other. And then we have plus v0 squared, 1/2 v0 squared over a. I'm going to write it as 1/2. And this other one then is minus 1 v0 squared over a. Now coming down to this next step, we can factor out an a. So delta x is, actually let's wait on that for a second. We have v squared, this is our only v squared term. And we have minus v0 and plus v0. So that means these two terms drop out. They add up to 0. And we have minus v0 squared and 1/2 v0 squared. So that means we're left with minus 1/2 v0 squared a. So now we have 1 over v squared a minus 1/2 v0 squared over a. So now we can factor out that 2a. V squared minus v0 squared. And now we can multiply both sides by 2a. And that gives us 2a delta x. And v squared minus v0 squared. And adding v0 squared to both sides would give us v squared equals v0 squared plus 2a delta x. And if we look at our starting equation, lo and behold, that's what we have. V squared equals v0 squared plus 2a delta x. That's where it comes from, and why you hear me say we don't really need this formula for anything. There isn't anything that formula can't do for us without us putting into this formula, getting an answer, and putting that answer in over here.